Welcome to lesson 6.4. Now, up to this point, we have been doing what are called indefinite integrals, which is just basically like general integrals. Today we learn about a new kind of integral called a definite integral, right here, our definite integral. Now, a definite integral is written with upper and lower limits attached to the integration expression. So this would be called my upper limit. This would be my lower limit. Now this may be thought of as a signed area, which we'll talk about more in just a second, from the lower limit A, usually the left side boundary, to the upper limit B, usually a right side boundary, between the curve and the x-axis. So here's what we kind of mean by signed area. Let's say I have a quadratic, and this is at 1. Oops, that's supposed to be 1. And this is at 5. If I want to know the integral from 1 to 5 of this function, then I'm going to think of it as the area between the curve f of x and the x-axis that I've now shaded in. Now we say signed area because if this area is below the x-axis, I think of it as negative. If this area is above the x-axis, I think of it as positive. So if I wanted to do the limit from, say, 5 to 6, or sorry, not the limit, the integral from 5 to 6, that would be this area between the curve and the x-axis. So that's what a definite integral is. It's the area under the curve is kind of how we think about it. Now, it says right here, the value may be positive, negative, or 0. Unlike the previous integration process, which was an indefinite integral, a definite integral represents a number value. So for all of these problems, our final answer should be a number. Now, we're going to learn how to do this by hand and by using a calculator. Now, there's two different methods for finding this definite integral by a calculator. In the next video, we'll talk about both methods and compare the pros and cons of each.